Greetings, programs. It's Kilpatrick here, back with another exciting video for you to consume. Okay, we are going to work on the chi-square problem set. I'm going to do a couple problems for you. You can see that I have set this thing up in Word or also as PDF, depending on what kind of device you're looking at it in. There's a lot of numbers on these pages. So I'm going to click the PDF and look at it this way. Okay. Once again, I've been generous enough to give you not only chi-square problems, but more differences between mean problems and more probability problems and more central tendency and dispersion problems. Yes, yes. You're only responsible for the chi-square problems for the assignment, but I'm giving you that other stuff in case you want to practice, so you'll be totally prepared for the midterm. Okay, let's look at problem number 1 here. A softball coach is trying to find outfielders for his team. He has 5 girls but needs only 3. He takes all 5 out to the field, hits a bunch of fly balls, and tallies up how many each girl catches. Use the chi-square test for significance to see if the amount of balls caught by each girl matches a hypothetical population distribution evenly divided among all 5 girls. So this is a problem with only one row of data. Okay, you can see the first row has the F sub 0. That means those are the observed frequencies. The second row are the expected frequencies. And the way I found that, remember, was I just added these numbers up. 9 plus 10 plus 6 plus 11 plus 14, that equals 50. And there are 5 numbers there, so I divide by 5, and that gives me an expected frequency of 10 for every one of these numbers. Okay, so after I have the observed and the expected frequencies, then I need to set up all the fractions according to the chi-square formula. And this is the fraction that you're looking at. The observed frequency minus the expected frequency, you're going to square that result, and then divide that by the expected frequency. So that's what I have here, right? For the first player, their observed frequency is 9 and the expected frequency is 10. So I have 9 minus 10. I'm going to square that result and divide that by 10. The second player has 10 for observed, 10 for expected. So 10 minus 10, I'm going to square that and divide that by 10. And again, down the line. The third player has 6, the fourth player has 11, and the fifth player has 14. So I set up all these fractions, and then it's just a matter of working through the problem. Okay? Now, I know I put one giant line here and here, but I want you to think of these as individual fractions. If I work 9 minus 10, that gives me -1. And I need to square that. And then I'm going to divide it by 10. So that's what this is right here. The second fraction, 10 minus 10, 0. I'm going to square that and divide it by 10. So that's this one. Okay? So you can see what I'm doing here. The last one, 14 minus 10 is 4 squared, and I'm going to divide that by 10. Okay? So that's what the next row of information is. If I square -1, I get 1. If I square 0, I get 0. If I square 4 on the very right-hand side, I get 16. So now I need to divide all these individual numbers by 10. So 1 divided by 10 is 0.1. 0 divided by 10 is 0. 16 divided by 10 is 1.6. The next one, 0.1. The next one, again, 1.6. And if I add all these up, I'm going to get a calculated chi-square of 3.4. When you have a problem with one row of data, remember, the way that you calculate degrees of freedom is it is the number of categories minus 1, or the number of players minus 1. In this problem, we have 5 players. So 5 minus 1 is 4. That's our degrees of freedom. If I look in the appendix, the chi-square appendix, and I'm going to find 9.49. Let's go find that. Here is the chi-square appendix. And right below this little blocked out area, you can see the degrees of freedom of 4. And if I start there and just move to the right until I get to the column with the column header 0.05, you can see that the number I'm looking for critical chi-square is 9.49. Okay? So that's how I get this. And then I have to decide whether I'm going to accept or reject the null hypothesis. So again, just like with differences between means, you're going to set up 4 values for me, okay? Now, we calculated the chi-square, not the t. That's my fault, okay? So the calculated chi-square is 3.4. And the critical chi-square, not the t, is 9.49. And degrees of freedom is 4. And we have to decide, are we going to accept or reject the null hypothesis? The answer is that we're going to accept the null hypothesis because this calculated t is not greater than the critical t. Okay? So you can refer back to this problem in order to do the second problem, right? When you see this on the midterm, this is all you're going to get, okay? And you need to work through the problem exactly like I've done here, step by step. Calculate the expected frequencies, set up the fractions, just keep doing the math as you go down, add up the numbers, get the calculated chi-square, find the degrees of freedom, go into the appendix, find the critical chi-square, and then make your decision. Okay? All right. Let's move on to a problem that I like because I love Las Vegas. Okay, this is the third problem. 4 of Kilpatrick's former students turn 21 years old and head to Vegas. The first game they hit is a roulette table at the Wynn Hotel, where they bet $1 on certain numbers or combinations of numbers until they exhaust their dollar chips. That's a little hint for you. Don't play the roulette wheel. Use the chi-square test for significance to see if the amount of turns taken by each student, red or black, matches a hypothetical population distribution arrived at by row and column marginals. Okay, row and column marginals is just multiplying a column total by a row total. That's what the marginal means, okay? So here's the original problem. Let's scroll down and look at problem 4. All you're going to get is one table with observed frequencies. So that's what I have up here. You know, here's my 4 students, Frenchie, Happy Girl, Cowgirl, and Sailor. And these 8 cells, 22, 31, 36, 26, 25, 24, 28, 29. Those are the observed frequencies. Okay. The other numbers are the column totals down here and the row totals over here. And then the total n, the total of everything, is in the bottom right. So the first table is observed frequencies. And then the second table, I'm showing you the calculated expected frequencies. Okay? So how did I get 24.5? Well, remember, in the lesson, it said that I had to multiply the column total times the row total. And when I get that, I'm going to divide by 221. So let's see if it works here. The column total is 47. I'm going to multiply that by 115 and get that result. And then I'm going to divide it by 221. And what I come up with is 24.457. So I'm just going to round that up to 24.5. And that's what I have here. Okay, let's go to the next one. In order to get the expected frequency for this cell of 31, I need to multiply the column total of 55 times 115. And when I get that result, I'm going to divide it by 221. So let's give that a try. 55 times 115, and I get that result, and then divide it by 221. Bing! And what I end up with is 28.61. So I'm just going to round that to 28.6, and that's what I have here. Okay? Again, the concept of what you're doing here is brand new, and that's why it's going to confuse you maybe and freak you out maybe. But the math is really not all that hard. You just have to take it slow and go step by step. Okay, let's look at the bottom cell for Saylor, right? My expected frequency here is 26.4. Now, how I got that was I multiply 55 times 106 and get that result, and then divide that by 221. And I get 26.38, which I'm going to round up to 26.4. Now remember, I'm in the second row of values, so I have to use the second or the bottom row total when I do my calculations. All right? That's how I come up with all of these 8 expected frequencies. I already have the observed frequencies. So the next step is just to put them in this fraction form. Remember, the chi-square formula, right, is the sum of all these individual fractions. Observed frequency minus the expected frequency. Square that number, divide that number by the expected frequency. Okay? So for the first cell, I have an observed frequency of 22, expected frequency of 24.5, and I create this fraction. 22 minus 24.5, and I square that number, and I divide that result by 24.5. And I just go right across the row using 31 and 28.6 for the next fraction, 36 and 33.3 for the next fraction, and 26 and 28.6 for the next fraction. And then I'm going to go down to the bottom row to get these fractions. The observed frequency is 25, the expected frequency 22.5. That's how I got this. And then I'm going to use 24 and 26.4 for the next fraction, 28 and 30.7 for the next fraction, and 29 and 26.4 for the last fraction. And once I have these set up, then it's just a matter of doing the math, okay? So if I do this top part, right, 22 minus 24.5, and I get that result and square it, I'm going to come up with 6.25. The next one, 31 minus 28.6, and if I square that, I'm going to get 5.76. Let's see if that actually works, okay? 31 minus 28.6 gives me 2.4, and if I square that, I'm just going to multiply it by itself and come up with 5.76, and that is what I have right here. Okay? So just keep doing these top parts and, pull down the denominators. So for the bottom row, let's do the last one here. 29 minus 26.4 is going to give me 6.76. So let's see if that works out. 29 minus 26.4 equals 2.6, and I have to square that. So I'm going to multiply it by itself and get 6.76, and that's what I have here. Okay? So now that I have all of the numerators figured out and I've moved down to the next section, then all I need to do is do the division for each fraction. Okay? So let's start with the first one. 6.25 divided by 24.5. And I get 25 or 0.255. So I'm going to round that up to 0.26, and that's what I have here. The next one is 5.76 divided by 28.6. So let's do that. 5.76 divided by 28.6. And I get 0.201. I'm going to round that to 0.20, which I have right here. Okay, I'm doing every division for each fraction and putting a plus sign in between them. So let's try the last one. 6.76 divided by 26.4. 6.76 divided by 26.4. And that gives me 0.256. So I'm going to round that up. Here's the last fraction, and here's the last number, 0.26. I have 8 fractions. I have 8 numbers to add up. And when I add all those up, I'm going to get a calculated chi-square of 1.92. I find the degrees of freedom a little differently than the first problem. Remember, when you have more than one row, you need to find the number of rows minus 1. There are 2 rows, so that's 1, times the number of columns minus 1. There are 4 columns, so 4 minus 1 is 3. So 1 times 3 is 3. That's my degrees of freedom. And if I go into the appendix, again, the chi-square appendix, go down the degrees of freedom column until I find 3 and move directly to the right until I get to the 0.05 column. I'm going to find 7.81. So let's find that again. Okay, here's the chi-square appendix. I'm going down in the degrees of freedom column to 3 and moving directly to the right until I get to the 0.05 column, and there's my number, 7.81. So that's how I found this. So I have everything I need to make the decision. Will I accept or reject the null hypothesis? I'm going to accept it because the calculated chi-square is not greater than the critical chi-square. All right. Sorry about the T there again. I screwed up. That's from the last problem. What I mean here is that I'm accepting it because the calculated chi-square is not greater than the critical chi-square. Okay? Forget the T, please. All right? So you can use this problem as a guide to do number 4, which only has the table with the observed frequencies. Okay? So I want to say a little something before I stop this video. I know we're all in super stressed out shape. I would much rather be at school with all of you. I miss my students so much, and I have tons of fun in the classroom. But unfortunately, we are where we are, and we have to do it online. So I know you can do this. I know you can. The concept is bizarre, but the math and the procedure is fairly simple once you look at it a few times. Okay, so give yourself a break. Don't give up, and just work your way through. Okay, I'm super proud of you. We're all the way through the end of the math, and I just want you to know how I feel. So I'm pretty sure I know how you feel. All right, this has been incredibly stressful for me, but we're gonna make it. We're gonna make it to the end of the semester. Okay, next week we're gonna do review, and then we'll have the midterm after that. And hey, it's a take-home midterm, so you get a whole week to do it. All right, all right. I'll see you in the next video. Keep your chin up and take care, everybody.